This is the movie that I promised about the test that we had this week. I'm going to do quiz A. Your quiz may be some other letter, which if it is, your numbers may be different. But the steps are the same for all the problems. So number one, how much energy is required to raise a temperature of 10 grams? So you know 10 grams. You know there's a temperature change. The key thing is knowing that there's a temperature change because that tells you to use this equation. So you write the equation. Q equals mCp delta T. You know mass is 10 grams, and you would put that in. You know that the specific heat capacity is given to us in a problem, and that would be 0.9 joules per gram degree centigrade. Okay, so 10 grams, 0.9 joules per gram degree centigrade. Then you got to multiply by the change in temperature, which from 10 to 25 is a 15-degree change. So now when you actually do the math, you have 10, I'm doing that on a calculator on the side, times 0.9, multiply that by 15, and I get 135. So the answer to that question is 135, and the unit is joules because grams cancel, degrees centigrade cancel, you're left with just plain old joules. So notice that joules represent Q. CP is represented by joules per gram degree centigrade, so they are different units. Joules, plain joules, is Q. So that leads us into the next problem. Again, we have a temperature change because it tells us we're going from 10 to 50. So Q is equal to mCp delta T. And why am I using this formula? Because there's a temperature change. So the mass is 100 grams. I'm just going from left to right here with what I'm given. Temperature change from 10 to 50. So that'd be a 40-degree temperature change. We don't know what the heat capacity is, so I'm going to put X in there because it says what is a specific heat. We do know that Q is 1500 joules. So now I have 100 times 40, which is 4,000. And the unit on that would be GC. Because nothing cancels, you have grams times C. So just like X times Y is XY, grams times degree C is grams degree centigrade. You also have an X there. On this side, we had 1500 joules. Now we need to simplify. Many students have told me that the way to simplify this is divide both sides by 1500. Then other students say, well, you got to subtract 4,000, but you can't do either one of those. You need to isolate the variable that is on the side with the number. So you got to get this variable by itself. So the X has to be gotten by itself. So to do that, you divide both sides by 4,000 GC. That way they cancel. Everything over here cancels. So on this side, I divide by 4,000 again. 1,500 divided by 4,000 is 0.375. Another problem that we often have is I see students dividing the big number by the small number. So you're dividing the 4,000 by 1,500. It must be 1,500 divided by 4,000. So X is equal to 0.375. That's the end of question 1 and 2. I just had someone walk in to ask me a question, so I'll come back and do the rest of it in just a moment. So I'll just post this one as a separate video.